Most people think screws are made in giant factories with millions of dollars in equipment. But the truth is, one well-set screw-making machine can run inside a small workshop and produce real sellable stock every day if you understand the full operation. In this video, I'm covering only one machine in full detail, the screw-making machine. I'll walk you through every stage of the process from raw wire to finished screws, how the machine is set up, what each part does, what can go wrong, and how small businesses actually run it for profit in a realistic way. This is the screw-making machine, and its entire job is to convert steel wire into finished screws with consistent length, head shape, and thread. The machine does this by combining feeding, straightening, cutting, head forming, and thread rolling into a step-by-step production flow. Most small workshops use a semi-automatic or automatic cold heading screw machine plus a separate thread rolling machine. Some machines combine steps, but the classic profitable setup is two machines because it's easier to maintain and gives better output control. Let's start from the beginning. Your raw material is usually low-carbon steel wire in coil form. The wire diameter depends on the screw size you want to produce. The coil is placed on a decoiler stand so the wire can unwind smoothly without tangling. From the decoiler, the wire moves into a wire straightening unit. This unit uses a series of rollers arranged in different angles. The rollers remove the coil memory and make the wire straight because a bent wire will create bad screws and frequent jams. Straightening is not a small step. If straightening is weak, the cut length will vary, the head will be off-center, and the thread rolling will create defects. After straightening, the wire enters the feeding system. Feeding is controlled by a servo motor or mechanical feed. You set the exact feed length based on the screw length you want to produce. This is important because every screw starts as a blank with a fixed length. The machine feeds wire forward, stops, and then the cutting station cuts that piece. The cut piece is the screw blank. If your feed length is even slightly wrong, the screw will be too long or too short and it will not match market demand. Now the cold heading stage begins. Cold heading means the machine forms the head of the screw without heating the metal. It shapes the metal using force and dies. This is where the machine becomes powerful. The blank is held in place by a gripping mechanism. Then the punch pushes the metal into a die cavity to form the head shape. This is how you get a pan head, countersunk head, hex head, or other types. The die controls the outer shape and the punch controls the inner detail. For example, if you are making Phillips screws, the head is formed and then a second operation forms the cross slot. If you're making flathead screws, the die forms a tapered head shape. Many machines use 2-die or 3-die heading depending on complexity. Here's what's happening inside during heading. First, the blank is positioned. Second, the first punch forms the rough head. Third, if needed, a second punch refines the head and creates the drive recess. This could be Phillips, slotted, Torx style, or hex socket, depending on tooling. The machine repeats this cycle very fast. Each cycle produces one headed blank. The speed depends on machine size. Small machines may run slower but still produce thousands per hour when stable. At this point, you have a screw blank with a finished head but no thread yet. The body is still smooth. The next stage is thread rolling, and this is where the screw becomes a screw. Thread rolling is not cutting threads like a lathe. It is forming threads by pressure. This is better for strength and speed. The headed blanks are collected and moved to the thread rolling machine. In many workshops, this is a separate machine located next to the heading machine for easy flow. The thread rolling machine uses 2 flat dies or round dies. Flat die type is common for small businesses. One die stays fixed and the other moves. The blank is placed between the dies. As the moving die slides, it rolls the blank and squeezes the metal into the thread pattern. The thread shape is engraved into the dies and the metal flows into that shape. This creates consistent threads fast. The important point is that the die set must match the screw type. Wood screws have different thread geometry than machine screws. Self-topping screws have sharper thread profiles. If you use the wrong dies, the screws will not bite properly and buyers will reject them. Technically, thread rolling also requires correct blank diameter. If the blank is too thick, the rolling pressure overloads the machine and causes cracks or distorted threads. If the blank is too thin, the threads become shallow and weak. This is why wire selection and die selection must be planned together. A good operator doesn't guess, they test small batches and measure. Transition over. After threading, the screws come out with sharp edges and may have oil residue from the machines. Next comes finishing and surface treatment. Many small workshops do basic cleaning first. Screws are usually washed or degreased to remove oil. Then they may be dried using a simple drying setup. Business reality, after cleaning, many screws are sold plain steel if the market accepts it, but most customers prefer anti-rust finishes. The common finishes are zinc plating, black oxide, or phosphate coating, depending on use. Workflow. If the workshop does not have plating equipment, they often outsource plating to a local plating service. This is very common and keeps startup cost lower. You manufacture the screws, pack them in sacks, send them for plating, then bring them back for final packing. Note, if you do in-house plating, you need a small plating line, chemicals, water management, and safety controls. That's a separate business layer. Many beginners start with outsourcing until volume is stable. Now let's talk about quality control, because this is where small businesses either survive or fail. Quality is checked in three main areas: length, head shape, and thread accuracy. Length is checked with a simple gauge or caliper. Head shape is checked visually and with a head gauge. Thread accuracy is checked with a thread gauge or by test fitting into standard nuts or sample materials. Firm. If your screws are inconsistent, hardware shops will stop buying because they get complaints. Consistency matters more than perfect beauty. Problem awareness. Common problems happen in predictable places. If the wire is not straight, the heading will be off and the head will be tilted. If the punch or die is worn, the head will have cracks, soft corners, or bad recess shapes. Continued, if the feeding length slips, you'll see length variation. If the thread rolling dies are worn, threads will look flat or uneven. If rolling pressure is too high, threads can crack or the shank can bend. If lubrication is too low, dies heat up and wear faster. Reassuring, these problems are not disasters if you catch them early, but if you ignore them, you lose whole batches. Operational tone. Maintenance is part of daily operation. At the start of the day, the operator checks bolts, lubrication levels, and die tightness. During operation, they monitor sound and vibration because a new strange sound usually means a misfeed or a die issue. Closing the loop, at the end of the shift, the machine is cleaned, metal dust is removed, and the feed rollers are inspected. The biggest long-term cost in screw making is tooling. Dies and punches wear out. A successful small shop keeps spare die sets and budgets for replacements. Business strategy. Now let's talk about the actual small business workflow, the way real workshops run this machine. The smart approach is to start with one high-demand screw type, for example, a common size used by furniture makers or local contractors. Measured growth. You produce that size consistently every day. You don't try to make 10 types at once. Consistency brings repeat orders. Once you have stable buyers, you add a second size. This is how small workshops grow without chaos. Cost breakdown. In terms of machine cost, an entry-level screw cold heading machine can range from around $3,000 to $10,000 depending on size, automation, and output speed. A thread rolling machine often ranges from $2,000 to $8,000 depending on type and capacity. Clarity. Tooling sets are extra. Die sets and punches can cost hundreds to thousands of dollars depending on complexity. Many people start by buying used machines in good condition and then invest in new dies for the exact screw type they want to produce. That is often more cost-effective than buying brand new machines immediately. Realistic earnings. Now, the earning side, without hype. Earnings depend on screw type, market price, and production stability. Screws are low margin per piece, but they sell in large volume. Calculated, a small setup might produce 10,000 to 30,000 screws per day at stable operation, depending on size and speed. If you sell bulk bags to hardware shops or furniture workshops, your net profit might be around $0.005 to $0.02 per screw, depending on material cost and selling price. On the low side, even if you net $0.01 profit per screw and you move 15,000 screws in a day, that's about $150 potential per day. If you have better buyers and steady orders, you can push higher, but volume and steady buyers are what matter most. These are estimates, not guarantees, and they depend on your local pricing, raw wire cost, and how well you control quality. So that is the full operation of a screw-making machine, from wire coil to finished threaded screws, including heading, rolling, cleaning, finishing, packing, quality checks, and the real workflow used by small shops.